Hey, everybody. How's it going? I'm Judah Phillips. I want to thank Pep for having me back at another one of his events. The last time I was on stage at one of Pep's events, it was 3:30 a.m. my time, the night after the CXL party. So a very different presentation for all of us, and I'm so happy to be here during the day. And today I want to talk to you about how I learned to stop worrying about AI and love machine learning. Does anyone know what I'm referring to here? Show of hands. All right, we have some film aficionados here. And I know we have some international folks, so I wanted to make sure we had languages represented. So this is a satire about nuclear war that Kubrick did in the 1960s, one of his first films. And I'm glad a few of you have seen it. I feel it's relevant to AI today. How many people have seen this movie? Hands up? Oh, come on. Who hasn't seen this movie? This is what a lot of people talk about when they think about AI, right? This Skynet. It's going to destroy the world. And Kubrick kind of riffed on this as well, right, in another movie. Can you believe it's 2019? I remember thinking about 2001 in 1992. It's so far away. Now, HAL 9000. Do you remember who HAL was? Sentient artificial intelligence with a little bit of an attitude, right? Let's go further back now. This is Fritz Lang in his Metropolis. This is the first robot in film, right? It's a bit dystopian if you ever watch this, this movie as well. Now, why am I telling you all of this, right? Because the common theme today that I've heard a lot of is that AI is going to destroy the world. It's going to put everybody out of jobs. It's going to create haves and have-nots. It's going to cause massive cultural change. That part may be true. But the rest of this dystopian stuff is really just overrated. It's fear, uncertainty, and doubt. As a matter of fact, just last week I was on a panel in my hometown in Boston with the chief architect of Wayfair and the gentleman who runs Microsoft's product management for Azure ML, and we got protested. I literally had people stand up in the audience and accuse me, Ben Clark, and Goshen, and Microsoft of being terrorists and killers because we're AI executives, right? And I sort of said, well, do we blame the knife maker, right, when somebody gets stabbed? So this fear, uncertainty, and doubt right now is all the rage with AI. Now, what's really underrated is AI for human augmentation. The idea that machine intelligence can help we analysts, CROs, business professionals who have no machine learning knowledge to do their jobs better, to make better predictions, to be able to understand the outcomes, to be able to look forward when making decisions instead of in the rearview mirror with things like KPIs and dashboards. Now, when you start to look at AI, right, again, there's a lot of talk about the singularity and sentient intelligence and scary Skynet stuff, artificial general intelligence, AGI. I don't think that'll ever happen in our lifetime. Maybe if little green Martians visit us or something like that and share their technology. But what's really going on right now is what I call pragmatic AI. And how many of you use AI chatbots? Drift, for example, my friend David Cancel's company. All right, cool. So you start to see a little bit of AI immersion into the marketing contact ecosystem. Or the way that cars are dispatched in some of the ride-sharing services, how they match you with riders, how quickly it takes you to pick up, those can be driven by classification algorithms or regression algorithms. I know we have the human Alexa, but we also have the machine Alexa and Siri. And these are artificial intelligences that seem really smart, but Siri just gives you a bunch of canned responses and fails most times, at least for me. How many of you had an Amiga computer in the 80s? Do you remember Raptor? Raptor used to talk to you. It just would spit psychology back and forth on the Amiga. It's not that different than talking to Siri. This was 30, 40 years ago now. But of course, the big thing that we all know about are autonomous vehicles, which many of my friends who have worked on them, they're a little bit bearish, right? They're taking a little bit more time to roll out. But regardless of Tesla's autopilot, we're really starting to see AI enter the workplace and enter our lives in many different ways, whether it's recommendations on Amazon or other experiences that we see within the digital ecosystem. I had a vision a couple years ago. I got really tired of doing digital analytics. Like, to be honest with you, I think I forgot more than most people will ever know about web and digital analytics. And I started to do these high-level strategy for these big companies. So, like, I developed machine learning strategy for Best Buy. And they've done pretty well last couple years. I pat myself on the back a little bit, but I started to think, like, how can, with these large companies, these strategies be executed? They required inordinate amounts of resources, it seemed, lots of complexity, programmers. We'll talk a little bit more about that later. And I thought there's got to be a better way. Can I find, a capability that allows me to apply machine learning easily across any industry for any use cases possible? And I kept looking. And I wanted something that was codeless. I didn't want to have to hire data scientists. I didn't want to have to write code myself in Python or Java, right? I've kind of been there, done that. I moved on in my life. And I wanted something that, like, Mark Benoff would appreciate, no software, right? A SaaS, something Pep, I think, is a big fan of with the CXL Institute. Now, why did I start thinking this? I mean, obviously, these strategies that I was doing for these big companies were really influencing me. But I really did it because I believe in AI as a human augmenter, as something that's going to make our societies better, something that's going to allow us to control our destinies, the destinies of our countries, the people in them. It's going to empower people, not disempower people. I want to ladder people up to the upper right quadrant and get out of the fear and uncertainty and the doubt in the lower left quadrant. And obviously, I'm not the first person to think of this, right? You guys have probably thought of this before. And a lot of other people have in the past. This type of thinking about machines augmenting humans is decades old, right? More than 60 years old. You have Newman, who must have watched a little of Fritz Lang's movie, self-reproducing automata. You have Turing. How many have heard of the Turing machine, Turing test, right? He talked about using computing machinery for intelligence, 1950, right? Was that 69 years ago? And then Simon Newell and Shaw theorized that computers could create logic and do theory using logic 3 years before the term machine learning was ever coined by Dr. Samuels. And we're going to go through this really quickly here. You have Dr. Engelbart in 1968. Have you guys ever seen the demo? How many people have seen the demo? All right, we're going to just watch a little bit of it because I don't have enough time to show you all 45 minutes or even the 5-minute clip I had. But what Engelbart did is he wanted to produce human thought products out of complex information systems, right? Sound kind of like the Gestalt of today. Let's go over to the demo. I'm going to hope this plays. Well, it didn't play. Let's see if we can go back. Can we click on it and play it? AV guys in the back. No? All right. Well, I encourage you guys to watch the demo. What you'd see here is an actual webcast in 1968 across the ARPANET. The mouse was invented. Mouse tracking was invented. It's a very powerful mother of all demos that allows you to see how people in the late 60s, while they're inventing the internet, thought about how humans could be augmented with a machine intelligence. And so what I'm here to say, some 51 years later, is that codeless AI, right? Not the AI that you have to code, but codeless AI is going to be your new best friend in the next decade. And when we start to talk about what does that mean, what is AI, there's a lot of confusion around it, right? AI is really systems that think like humans, right? They use logic. They may include conditional statements, decision trees. Things like deep learners would be considered artificial intelligence. Essentially, anything that takes historic data, it's called training data, and learns from that training data about how the past performed, is called AI, right? Supervised machine learning that can then use that training data to predict on the future. So if I had a bunch of leads and I knew which ones converted or not, I can then predict which of my new leads would convert by learning from that past data. When we talk about traditional machine learning, it's often considered a subset of AI, and it's focused on tasks. So if I wanted to cluster data together to see which answers are most frequently picked in a survey across multiple questions, I could use a clustering algorithm. Or if I was an e-commerce analyst, I could use an affinity analysis or a market basket analysis to understand the co-occurrences between items in my data. Is milk bought more with cheese? Is bread? And then, of course, there's deep learning, which is this idea of neural networking. And this is in the hype of inflated and maybe overinflated expectations right now. Things like convolutional neural networks. How many of you used Google's deep mind technology to determine what art you looked like the most. Anybody use this? A few people. Okay, and then other types of usages for deep learning are things like, you ever see Trump saying Obama words or Obama saying Trump words? Deep faking, right? This is going to be using generative adversarial networking, something that's going to impact us in the future. And all of this stuff actually applies to data analysis and CROs right now. And why, again, is this important? Well, about 15 years ago, do you guys know Brian Eisenberg? It's like one of the fathers of conversion. He lives in Austin. He met with me and he said, hey, Judah, things are changing. And before I knew it, we had iPhones and social media and the massive digital ecosystems that we have today. We're at the precipice of another change, right? So it's important to start understanding what's the difference between AI and ML and deep learning, and how do I apply it in my jobs? And when you apply it in your jobs, what do? Well, you can certainly predict, right? You can predict the probabilities of an entity across two classes. Are they going to churn or not churn? You can identify which offers to sell. So if I have 10 offers and I know which ones had the best response, I can then predict the right offer to send to that individual on a one-to-one marketing basis, and then predict the probability of those other 9 offers being chosen. And you can use it to accelerate innovation. You can use it to obviously do personalization, right? Learning about what elements to serve and what content to serve is actually something that Microsoft does internally right now. So at Microsoft, they have AI that's recommending who you should talk to at Microsoft, what artifacts you should look at, what decks you should review, what videos you should use. So to personalize content, obviously to sell, right? Account-based management, figuring out which leads are to convert. Again, I'm a little tired of last, first, equal, weighted, decayed attribution. Algorithmic attribution is possible, way beyond the capabilities we see in some of the traditional tools, and even some of the cool stuff that Google's doing in 360. You can obviously figure out and forecast lift based on actions you take in your business, and of course you can predict blame. But where's AI today? What AI is, all those things I just explained, what they really are, they're just mathematical concepts that have been expanded on and added to over time. And as a result, there's these great algorithms that now exist. Many are open sourced, right? Like XGBoost, for example, which does gradient descent. You can simply go and download that, and if you know how to code it up, you can start to do some really cool predictions that are provable based on past testing. It's called cross-validation. And you can then apply them. But still today, most people believe that you need really clean data, you need a lot of data, you need very expensive data scientists who can often be inefficient and take a long time to do things. But the reality is that that's not true. Let me just ask you a few questions. Bayesian and frequentist. Who's a Bayesian in here? Come on. Admit it. All right, who's a frequentist in here? Who's never heard of these things? I figured I'd be having, left and right, the CRO. Don't you guys very much, wax poetic about this? All right, but what about who's Gaussian? Lorentzian? I like this guy over here. He's like, yeah, I like Gauss. It's pretty cool. I like that blur. How about Leibnizian? Schopenhauerian, right? Are you guys these things? Well, the reality is, who cares, right? Because these are academic arguments that I'm surprised that Pep even allows on his platform. But these are the people of today. Enough with the dead European white men, right? How about these guys? So Jeff Dean, what does he do? Deep mind. Sebastian Thurn, look him up, pretty interesting guy. Siobhan is literally creating machine intelligence right now, one of the leading AI researchers. And Carol is one of the people working on the most advanced autonomous vehicles. Now, we all know who Elon Musk is, right? He's developing AI that he can't even release because he's so afraid it's going to destroy the world. What about Gina Rometty? Who's that? CEO of IBM, Watson. You know what we call Watson in the AI world? The Donald Trump of AI, right? Why? Because it constantly overpromises and underdelivers. All right, so all these modality arguments, they don't do right? What I really like to do, I'm a capitalist, right? We like to make money. You agree, Pep? It's good to make money. Tell you a lot about nature, tell you a lot about crowd theory, physics, electronics, but what if you're selling body lotion? Like, how is all this stuff going to help you? How do you take advantage of AI if you're trying to predict churn for your SaaS business? Well, you have to start learning about it, right? And what I've learned about ML is it's more human than you think, right? In many cases, even the best researchers, like Jan LeCun at Facebook, every time you click on translate, that's a little AI kicking in your daily life. They don't even know how it works, right? Machine learning explainability is a big theme over the last year and a half in AI, and it's becoming more and more important. But still, just like humans, we don't really know how we learn, right? Maybe we know we read better, or we learn from watching or doing, but just like machine learning, we need to be trained. And then sometimes you just have to stumble around in the dark. That's how I learned to do web analytics in the late 90s. Nobody was doing it, you know? You just, I don't know, there's NetGenesis, there's analog, log files, and you stumble around till you figure it out. Now here's the thing, even though ML is like us, right, it's also better than us at certain things, right? Pattern detection, understanding relationships in huge volumes of data. It's fast. How do you look at 10 million rows and determine what's important as a human? You know, you'd be quitting your job if someone asked you to do that. It also can be unbiased, right? People say, what about biasness? You know, these lending programs are biasing on protected classes. Well, you know how you solve for that? You just remove the protected class information from the data. It's not that big of a problem. And this is really where I've been focusing a lot of time and thinking, and I encourage you guys to think a lot about how you apply AI in CRO and in marketing analytics and in your business decisions. Supervised machine learning, you know, a convolutional neural network, a CNN, is what can tell you it's a cat or a dog, right, or a frog, or an alligator, right, just by passing in some pictures. Now, machine learning is also a pragmatic AI. It's not going to destroy you. It can see, right? Machine vision is real. That's how these cars are driven. What is this? This is a robot detecting the needle in a haystack, right? All right, so supervised ML is your workhorse. Here are some use cases. I'm going to go through these quickly. Which leads are going to convert, right? That's binary classification. We'll talk more about that in a second. Which customers are going to win? Who's going to churn? Who's going to have the highest lifetime value? Can we forecast how much they're going to be worth? What offer should I send? What personalization should I do? What UX elements are most critical to conversion? There's variable importance, ranked orders of the data, and that's most important to your prediction. Which elements should I serve? Which are most important to the goal? Which segments are people going to be in next? Predictive segmentation. Right? These are things you can do. And as I mentioned, the variables you use in these models become a part of the explanation. They can be rank ordered. So you know that the last marketing click is less important than going to the CXL conference in terms of a customer lifetime value for CXL. For all these things, you can determine what's actually driving them from the data you believe to be causative in your business. Now, it's important to know the model classes. This is something like remember. Like this is important slide right here. Binary classification. This is when you predict the probability of an entity being in two classes. Yes or no, true or false. They're going to buy, they're going to churn. Is the machine going to fail or not? Multinomial or multi-class classification is when you're predicting the probabilities across 3 or more classes. So knowing the lifetime value of my customers, can I then predict who's going to be high, medium, or low lifetime value? Or, for example, Walmart has 48 different trip types. Are you a daily shopper, a weekly shopper, a school shopper, a monthly shopper? They use their product selections and their receipts to predict what your next shopping experience is going to be so they can personalize offers to you. And then regression is predicting the movement of the next period value in a continuous variable, like a forecast. But the cool thing about machine learning is it's not just numbers on a timeline. You can use categories, right? You can use dates. You can even use strings and change the strings into vectors and use a lot more in your modeling than you would traditionally do even in general linear modeling. So all of this can be automated. This is the cool thing. Like 2 years ago, you couldn't say this. You know, automated machine learning, this was the solution for me, right? And something that revolutionized what I started, when I wanted to do more than just looking at KPIs and dashboards and trying to drive forward while looking in the rearview mirror. I realized automated machine learning and all this cool stuff, right? Bayes fans, right? Still in machine learning. So those things still apply. I was joking just a little bit. But the idea is all of it can be automated. You don't need to learn these underlying algorithms, right? All of it can be automated for you. Automated hyperparameterization, automated holdout, validation, cross-validation, all that cool stuff, if you know what I'm talking about, can all be done automatically without humans ever touching it. As a matter of fact, AutoML can produce Java bytecode models that you can then compile and run, right? So the machines actually write programming code. What you really need to know is how to interpret and explain the results. How many of you have seen a confusion matrix before? Hands? Cool. Everyone in here should know what a confusion matrix is. What about ROC metrics? How many Europeans here? ROC saved Europe, right? Receiver-operator characteristics, the same math in machine learning, was used to figure out which blips were Nazi planes on the blitz. AUC, you'll get a lot of legwork in your career right now out of knowing what area under the curve means. Random chance is 0.5. Any model that produces above 0.5 AUC is predictive power. Here's what a confusion matrix looks like. It maps your true negatives, your false positives, your false negatives, and your true positives. And these help you understand and tune the performance of a model. If you're diagnosing disease, you don't want to have a lot of false positives or false negatives, right? Marketing campaigns, it's all right, right? It's all right. And that's what a multinomial confusion matrix looks like. Very well named. Super well named is that you can do all this algebra off here. All of this stuff is how you evaluate the performance of a model. So if you're a CRO person, and now you're exposed to machine learning, it's not going to be on the algorithmic creation of the coding. It's going to be on knowing, like, do I even believe this, right? And how do you understand if you believe it or can use it unless you know what an F1 score is, right? What's the max F1? It's the harmonic mean between precision and recall. All of these things you need to know. Remember statistics, your sum squared stuff that in grad school, if you guys went? It's all relevant, right? Things like log loss, mean average error and mean average deviation, mean squared error, RMSE. These are all things that you need to know, like the definition of a visitor, right? All the different attribution models. This is the new stuff. This is what's going to make your career relevant in the future. And let's say that dystopia happens. It won't. This is going to keep you friendly with the robots, too. These are other things. Mean class error. What's residual deviance, right? All these slides, taken from a cheat sheet from Stanford's machine learning course, right? So you can simply just start downloading and reading this stuff now. You're going to learn new types of analysis, not just classification or regression, but remember your type 1 and type 2 errors, or ablative analysis. What is this? It's understanding the root cause of the difference between models, right? These are the skills that an analyst is going to need in the future. And, you know, what does AI and ML solve? Well, is it more usable? Is it more available? Is it more relevant? Is it timely? Is it smart? I would say the answer to all of these questions is yes. The biggest thing it's going to help us deal with is the onslaught of data. We're generating so much data. So it's hard to turn that information into insight, right? So you can do it with automated machine learning. And here's the deal. Most people aren't even doing this. Shocking, right? Where's the 26% that aren't even doing descriptive analysis? But this is the traditional web analytics stuff, right? KPIs, dashboards. 1 out of every 100 are doing prediction. We're using a prescription. What prediction should I actually take based on my ablative analysis? Or only 1 every 10 are doing predictive analytics. This helps you move from insights to action. Lots of data that you see is descriptive, right? Therefore, you have to react to it. You can report and sort, but what happens when it goes beyond 1 million rows? It gets a little difficult to start being practical with data of that size, and it's certainly not predictive. Data visualization, love it, right? The Domos, the Tableaus, the Clicks of the world. Great for understanding outliers and relationships. Maybe even get a little stack bar on your histogram and a regression line. But it's practical, but it's not really very predictive. If you have data like this, this is the type of stuff that AI is really helpful for. Which of these people are going to churn? Well, I can learn from my past data if I know who's churned in the past, and I can build a classifier in minutes that will predict, literally in minutes, better than hand-coded models that will predict which one of these works. As I mentioned, traditionally this has been costly, lots of data scientists, lots of lead times. It's resulted in big projects. For example, AutoML would allow you to upload your training data, upload your production data, automatically generate thousands of models, right, in minutes across many different algorithms, and then see your predictions. That's what you can do today. This stuff is available right now. People use it in marketing to predict how the movement through the funnel occurs. People use it to do account-based management. I know Pep has tried it before and has some modicum of success, even with some crappy data that he sent me. And also quantifying ROI, like algorithmic attribution. You know, I've seen agencies charge hundreds of thousands of dollars for lift models that, for a large OEM, we reproduced in a couple days that were much more accurate. Algorithmic attribution. So there you have it. If you learn this stuff, right, if you realize it's not so much about the geeky programming algorithms, that those are somewhat open source or commoditized these days, it's about figuring out how to activate those algorithms and use them in your business and understand how to interpret them so you can action on them correctly. You can invent new things, you can outclass your competition, you can overperform. And this is what we do at Squark. Free trial if you guys want it. Mention CXL, squarkai.com, free trial. Now, I'm going to leave you guys with one last thought. Who is this? Who is this? Any guesses? Who is this? Who is the frequentist? It's Sam Adams, guys. So he's going to be at tonight's party. I look forward to chatting with you guys throughout the next couple days while I'm here. I hope you enjoyed a quick overview of all the exciting stuff happening in automated machine learning. It's about interpretation and understanding how to get this stuff done quickly. It's not about coding and trying to figure out how to get the money to actually do this. So Excel 2029, right? That's what Squark is and where I work. Check us out. Thank you. I enjoyed being here. Thank you, Pep, for having me at 3 o'clock in the afternoon instead of 3:30 in the morning. And I look forward to talking to you guys at the event. Thanks.
All right, so we have time for just a couple of questions. The biggest one that's come up is, are there tools that could do this if we don't have AI resources in-house?
Well, I told Pep I would not do any pitching. So there's definitely tools that can do it.
Okay, good to know.
And they are in-house. What are the best tools for supervised ML for our CRO? You know, let's talk after, if anybody wants to know. There's a few people who do this. There's going to be a report that comes out in May that'll expose a lot of the people that are doing this. There's not many. So look for that from one of the great analyst groups.
And we'll just do one last one then.
I don't like to let Google do my job for automated optimizations, AdWords. Should we care how they optimize or just let them do it? That's a great question. I love Google. I've been to Building 41, hung out with Avinash, eaten at the No Name Cafe, been to Slice and all that stuff, seen the swimming pools. They also have a conversion probability in beta for Google Analytics. I tried to use it. I just couldn't really understand what it was telling me. So the great thing about automated machine learning, or just really any machine learning, is that assuming you do it right, you have a holdout, a validation, a cross-validation set, you can actually predict the accuracy of the model, because the model as it builds will, or once it's built, will hold out data from the past and score it to see how accurate the model is. It's kind of how you get AUC and some of these other errors that you use to understand models. And as a result, you can believe them to be generalizable at that same accuracy. And one of the challenges I see with a lot of the ML that gets embedded in products is you don't see any of that stuff, right? So I think you should care, and I would ask your account manager a lot of questions. And honestly, I don't think that well, Google's a different case, but I don't know how many big companies are innovating in this area. It's a lot of smaller companies. Maybe that'll work at big companies. And
all right, well, I think that's all the time we have. So
all right,
let's give it up. Thank you very much, Judah.
Thanks again, everybody. I'll see ya with some Sammys tonight.